We're here with Alan Nixon with Revelation Engineering, and you're a big topic of discussion here with the ICE World Conference 2025 because you've come up with an innovative idea, and that's a big part of what the discussion is here. Individuals having an idea and going through with it and then seeing the changes it can make in the world. And so it'd be nice if you could just kind of walk us through what you have going on, explain the invention that you've come up with, and then we could talk about it a little bit.
Well, big thing that I was approached with is three main problems with wind turbines. The one is the spinning blades and taking out the birds. The one is the maximum wind speed that it's able to work under. A traditional wind turbine caps out at around 60 kilometers an hour, and we all know that we see a lot higher winds than that on a very consistent basis around here. The third problem is mechanics at elevation, right? So those were the three problems that I set out to solve about 15 years ago, chewing on it and thinking through it. And that's where I came up with this idea for a bladeless wind turbine. The basic idea is that the wind comes in, it generates a negative pressure in here, goes down, and all of the pressure is then converted into rotation and energy using something like this that basically turns that negative pressure into rotational energy, and then you have electricity. This is a prototype. It's a very scaled down version of it, but the perks of this is, like I said, there's no moving parts, or there's no spinning blades, so we're not going to run risk for birds. It's able to operate at elevation, at 200 or not at elevation, at high wind speeds. So 200 kilometer an hour winds, this thing doesn't have a problem with it. It's not going to care if the wind speeds get high. It's not going to affect it at all. And the other thing is moving parts and serviceability at ground level. We have a relatively small piece of equipment that can have redundancy, so we have multiple of these engines. So if you have high wind speeds, you can use more than one. You have low wind speeds, you only need one. You shut all the other ones off, you only use the one. You have one that goes down, you shut that one off, use the other ones. You've got critical spares. The intention is for these to be entirely serviceable, for you to be able to take it apart, put it back together, and have it run. The motors that it's intended to work on are intended to be off-the-shelf motors. So nothing special, no specialty turbines that need to be ordered in, all off-the-shelf parts. And that's the basic idea. Talking with one guy here this morning, he brought up the one hazard of the spinning blades, where they need to account for those blades to actually fly off, and they need to think about that. This is a solid state device. All you have to think about, or it's all built solid, right? It's not going to fly off the way that one of the other turbines would. So there are also different sighting considerations, even from that this might actually have additional considerations on too. So we're really early in the development of this technology, and I don't think we've really captured have a really idea of how much impact this could have. But in theory, this could this could capture energy in places where it was never possible.
Another point that I'd make about the blades, since I grew up in southern Alberta where they do have a lot of the wind turbines, is when they have to transport them, with how long they are, how they literally have to shut down some towns just to bring them through. So I could imagine like it could be a smaller down or more pieced together kind of technology as well that would be easier to transport in the long run.
Possibly. That all depends on scalability. How does it scale? What size ends up making sense? The other thing is if we're wanting to deploy a large scale thing and transportation is going to be a problem, ease of manufacturing, I haven't talked on that yet. The other idea with this is it's all made out of just steel. It's all just simple steel. We can basically use just a laser cutter and a welder and get this thing thrown together. So we could just deploy, or we could get someone to build it closer to the location. Rather than all building it all in one place, we can just build it closer to where it needs to actually be installed. That might make more sense. So multiple different ways that this thing could be rolled out.
You mentioned that it's been a 15-year process, and I wonder if you could just talk about maybe some of the roadblocks you came along the way, maybe some of the lessons you've learned, and then some of the successes you've had during that time.
Well, one of the things that when I say I've been thinking on it for 10 years, like the problem was thrown at me 15 years ago. And I tried kicking around a whole bunch of different ideas that would address those problems in different ways. And every single one of those had its own problems. It was either too complex, there was too many moving parts, there was already things on the market for it, there was just no path. But when it kind of struck me how sitting in my house and just noticing how we had high winds, and the high winds were causing, as silly as it sounds, the water in the toilet to go up and down. That air moving over that pipe was causing water movement. Well, if we have water movement here, something's happening. So that's where I took the idea. I said, okay, well, if that velocity is causing a problem, or is causing it, let's make a higher velocity. Let's maximize this. Let's make this more efficient, and try and figure out a way to capitalize on this. Yes.
And then just to speak on your expertise with revelation engineering, just to talk about maybe how anybody can have an idea and kind of work through a process and make it happen. I'm just wondering how your expertise as an engineer has kind of played into this, and if there's just any other ways in your everyday life where you were able to draw insights into this.
Well, for myself, I'm a multidisciplinary technologist. So that means that I'm able to walk into a whole wide variety of areas and just look at the problem and say, okay, in this discipline you're going to run into this problem. This discipline you're going to run into this problem. This discipline you're going to run into this problem. So that's just the body of experience that I have, that I bring to all situations, and I have a troubleshooting just way of thinking. I look at a problem and I say, okay, what is the problem? And I ask the 5 whys, like break the problem down, at least 5 levels. By the time you break it down 5 levels, you're probably getting to the root of where the actual problem is. It's just it was the way that I was trained, and in general, it ends up working in a lot of different projects and different problem solving. So revelation engineering, that's what we do, is we solve problems. That's our goal, is to solve problems and make it painless for the end user. And this is just a random idea that I came up with, and there was nothing on the market. So I wanted to bring this to public awareness, because there's nothing like this. There's no idea like this on the market. I've looked. We've done the patent search. There's nothing like this. So,
last thing I want to ask you about is just what is next in your journey with making this possibly someday going into production?
The first thing that we want to do is we want to actually do some computational fluid dynamics with this. We've had a number of conversations with some people here about the path on doing that. It is a very specialized field, and it's one of those things where I could figure it out if I tried, but I wouldn't have any confidence in it, because I'm not an expert in that, and I know this is a limitation in my knowledge. So I'd rather get someone that has that expertise. But what that'll do is that'll give me confidence to say, okay, if I build this thing with this type of dimensions, it will work in this wind profile, and then we can say, okay, let's build one that has that dimensions, and then test it in that wind profile, and then prove out that this is going to be a viable technology, and see if we can roll this thing out, because there are a wide range of areas in which there's no way to actually get any wind power out of it. Like, it's just like we have high winds, right? High winds are high energy, right? It's just a waste to not be able to capitalize on that. So trying to find a way to capitalize on that.
Last thing, you hit on a great point about this conference and how it is a really great opportunity to network. You mentioned you've talked to a few people while you've been here, and I wonder if you could just speak to that, on how big of an advantage it is to have a conference like this where people can get together, brainstorm, and then possibly look to work together in the future.
That's one of the things that like, I've attended all the ICE conferences so far, and and I've been able to build networks. And a number of the guys that I've been having conversations here, that they're like, well, we can go this direction, we can go this direction, we can go this direction. This is the second conversation or third conversation or fourth conversation that I've had with these guys, because I've been building that network. And I've made some connections with some people here today that I've never met before, and some of those have been opportunities in terms of figuring out, okay, how do exactly do we take this to the next step? So,
Last thing, how can people reach out to you?
you can contact me at you can come or visit our website at revelationengineering.ca, or you can stop by our office. We're on Highway 18, just going outside of town, or give me a call. And if you have a problem with anything that you're looking to solve, feel free to reach out, give me a call, and yeah.
Thank you so much for your time.
No problem.